Okay, let's now have the last question here, Q5. We finished Q1, Q2, 3, 4, MCQ, and Q4. Now we have Q5. Here I put already the truth tables for the or and the and. This is not given actually, but to save time, I put it here. You can go back to your handout, page 2 or page 3, or propositional logic for the or and and. Okay, so as I said, this is not given. I just gave this one here for us to save time. But in answering this question, for example, in your test, you can refer to these truth tables. We have memorized this already. I have many examples of these in our previous problems. For the or, we have true or true is true, true or false is true, false or true is true, false or false is false. For the and, there is only one true, that is true and true, and the rest false. Now, we have here a scenario, and this is the diagram. Consider the system of components. So we have 4 components, component 1, 2, 3, and 4, connected as in the accompanying picture in this diagram. Components 1 and 2 are connected in parallel, as you can see here. So these are multiple edges. So in graph theory, we call this as multiple edges. They share common or the same endpoints, as you can see here. So that the subsystem, so this is our subsystem 1, containing 2 components. So we have 2 subsystems here. This is the whole system. This whole system from here until here contains 2 subsystems. The first subsystem contains 2 components, components 1 and 2. The second subsystem contains 3 and 4. Okay, so components 1 and 2 are connected in parallel, so that subsystem works if, so if here with double F means if and only if either 1 or 2 works. That means if 1 works, it's fine. If 2 works, it's fine. So if 1 only, it's fine. 2 only, it's fine. Or if both works, it's fine. Like this. True or true is true. True or false, that means exactly 1. True, false or true, exactly 1. So false or true means component 2 only. True or false means component 1 only. Still is true. And here, both components, component 1 or 2 works or work. So that's true there. Now here, 3 and 4, as you can see, they are on the same line. So this is series, connected in series. So this subsystem works if. So if and only if both 3 and 4 work, as here, shown here. True and true, that's true. So the rest would be false. True and false, that means component 3 only, that's false. Here, F and T, it means component 4 only, it is false. Here, both are not working, of course, false. So I hope you understand these tables here. So that is why propositional logic principle is very important. It helps us to understand other scenarios, other problems in life. So the component or the components work independently of one another. And P component works is 90%, 0.9. And calculate P system works. So independently, that means P of component 1 works, that is 90%. So P component works is 0.9. So this means that P component fails equals 0.1. That is 1 minus 0.9. If you cannot solve this automatically, use Excel equals 1 minus 0.9. It's gonna be 0.1. Okay. So these are the probabilities. Now these ones are not given, but I put these ones here to save time. On the test, for example, you have to put all of this. Okay. But anyway, this one to save time is ready. This is ready. This is ready. Okay, it's given. But if these are not given, you have to put this text here. Components 1 and 2, that is 1 or 2. So here we use or because they are parallel, multiple edges, they share the same endpoints. 3 and 4, that is and because it's series, they're on the same line. So if it is on the same line, use and. Parallel or different lines, use or. So let's start with subsystem 1 containing 1 and 2. So there are two subsystems, as I have mentioned before, 1 and 2, and 3 and 4. So these are separate subsystems. So this is subsystem 1. Okay, and subsystem 2. All right, so P work for this subsystem. There are 3 there. True, 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 because we have or. So it's more difficult if you're going to solve this one by one. So the best way is to use complementation rule because there is one opposite there, one F. So this is fail, fail. We have here 0.1. So 1 minus, we can use the complementation rule. So equals 1 minus the last row. Fail component 1 and fail component 2. So that is P work of this subsystem. So fail here is 0.1 times fail again component 2, that is 0.1. So it's easier to solve because if you're going to use P work directly, there are 3 possibilities there. True or true, true or false, false or true, which is longer. So the easiest way is the opposite. 1 minus the false here, that is true, true, true. So 0.99. Now P does not work is equal to 1 minus this, the opposite of P of work. So 0.01, the total is 100% or 1. Now for components 3 and 4, this one is and. There is only 1 there because we have and. True is true, so it's easy. So directly we can just multiply equals 0.9 times 0.9 because we have only 1 row there. That's 0.81 and the opposite is 1 minus 0.81. So that's 19% probability that components 3 and 4 do not work. Okay, so it means that this subsystem, let me just put this one here. This is subsystem 1, this is subsystem 2. Okay, so 19% here or 0.19. This is the probability that subsystem 2 containing components 3 and 4 does not work. Here, 1%, this is the probability that the subsystem 1 consisting of components 1 and 2 does not work. Now, the question is, you're going to calculate P system works. So P system works. That is the question. Okay, we can use this, but it's more difficult because these are different rows. So let's use the opposite complementation rule again, using does not work subsystem. Okay. So we can use equals 1 directly. So the probability that the system works is 1 minus subsystem 1 does not work, and subsystem 2 does not work. So we can use equals 1 minus, we have 0.01, or you can write it times this 0.19. Okay, so multiply these two. Subsystem 1 does not work, and subsystem 2 does not work. So that's the answer, 0.99.81. Then change to percent equals this. Select percent, increase 2 decimal places. Okay, so that's the answer. Thank you so much for watching. Until next time, bye-bye.